NEC Article 430 covers motors and motor circuits. NEC 430.22 requires a minimum branch circuit rating of 125% of the pump motor's full load current. In this case, the full load current is 12.0 amps, so the minimum branch circuit rating is 12.0 amps times 1.25, which equals 15 amps. NEC Article 250 covers grounding. NEC 250.50b requires the pump motor to be grounded using a copper conductor. The size of the grounding conductor isn't smaller than 12 American wire gauge for 15 amp circuits or 10 American wire gauge for 20 amp circuits. The grounding conductor should be connected to the motor frame and to the grounding electrode system at the service panel. NEC 430.109 requires a readily accessible disconnecting means within sight of the pump. The disconnect switch should be rated for the full load current of the pump motor, in this case 12.0 amps. The disconnect switch should be located close to the pump within sight of the motor. NEC 430.23 specifies the requirements for overcurrent protection of motor circuits. NEC 430.24 covers the use of controllers with motor circuits. NEC 551 provides additional requirements for water pumps. Local electrical codes may also have specific requirements regarding well pump wiring and installation. I'll now talk about recommendations. It is recommended to use a number 12 American wire gauge THHN or THWM-2 copper conductor for the branch circuit. It is recommended to install a 15 amp circuit breaker or fuse to protect the circuit. It is recommended to use a number 12 American wire gauge copper conductor for the grounding conductor. It is also recommended to install a single pole disconnect switch with a rating of 15 amps or more. It is essential to consult local electrical codes and a qualified electrician for final verification and approval. Let's delve deeper into the NEC requirements for well pump installations, expanding upon the initial overview. We'll begin with branch circuit wiring, then move on to grounding, disconnect switches, overcurrent protection, motor controllers, and conclude with additional considerations and recommendations. Regarding branch circuit wiring, NEC Article 430 provides comprehensive guidelines for motors and motor circuits. The fundamental rule for sizing branch circuit conductors is found in NEC 430.22a, which mandates a minimum branch circuit rating of 125% of the pump motor's full load current. This ensures that the conductors can handle the continuous load of the motor without overheating. In the specific scenario described, the well pump motor has a full load current of 12.0 amps. Applying the 125% rule, we calculate the minimum branch circuit rating as 12.0 amps multiplied by 1.25, resulting in 15 amps. Therefore, the branch circuit conductors must be sized to handle at least 15 amps. It's crucial to select the appropriate wire gauge based on the ampacity rating specified in NEC Table 310.15. For example, using THHN or THWN-2 copper conductors, a number 14 American wire gauge conductor is typically rated for 15 amps, but a number 12 American wire gauge conductor, with a higher ampacity rating, is generally preferred to provide an additional margin of safety and minimize voltage drop, especially over longer distances. Moving on to grounding, NEC Article 250 outlines the requirements for grounding electrical systems. Grounding is a critical safety measure that helps to protect against electrical shock and equipment damage. NEC 250.50b specifically addresses the grounding of motor frames, requiring them to be connected to the grounding electrode system. The size of the grounding conductor is determined by the rating of the overcurrent protective device in the circuit. For a 15 amp circuit, a number 12 American wire gauge copper grounding conductor is the minimum acceptable size, while a 20 amp circuit requires a number 10 American wire gauge copper grounding conductor. The grounding conductor must be connected to the motor frame and to the grounding electrode system at the service panel, ensuring a low impedance path for fault currents to flow back to the source. This connection helps to trip the overcurrent protective device, such as a circuit breaker or fuse, in the event of a ground fault, thereby preventing dangerous voltage levels from appearing on the motor frame. Next, we'll discuss disconnect switches. NEC 430.109 mandates the installation of a readily accessible disconnecting means within sight of the pump. This disconnecting means serves as a safety measure, allowing personnel to de-energize the pump motor for maintenance or repair purposes. The disconnect switch must be rated for the full load current of the pump motor, which in this case is 12.0 amps. Therefore, a disconnect switch with a rating of 15 amps or higher should be selected to ensure that it can safely handle the motor's current draw. The disconnect switch should be located close to the pump within sight of the motor, so that it is easily accessible and can be quickly operated in an emergency. It's also important to consider the type of disconnect switch. A non-fused disconnect switch is typically used for this application, as overcurrent protection is provided separately by the circuit breaker or fuse in the branch circuit. Overcurrent protection is another critical aspect of motor circuit design. NEC 430.23 provides specific requirements for overcurrent protection of motor circuits, aiming to protect the motor and branch circuit conductors from overloads and short circuits. The overcurrent protective device, which can be a circuit breaker or fuse, must be sized appropriately to allow the motor to start and run without nuisance tripping while still providing adequate protection against excessive current flow. The maximum allowable rating of the overcurrent protective device depends on the type of motor and its starting characteristics. For a typical well pump motor, the overcurrent protective device should not exceed 250% of the motor's full load current for an inverse time circuit breaker, or 175% for a dual element time delay fuse. In this case, with a full load current of 12.0 amps, the maximum allowable rating for an inverse time circuit breaker would be 12.0 amps multiplied by 2.5, resulting in 30 amps. However, it's important to select the smallest standard size circuit breaker that will accommodate the motor's starting current without tripping. A 15 amp or 20 amp circuit breaker may be suitable in this case, depending on the motor's specific starting characteristics. Motor controllers are often used in motor circuits to provide additional control and protection features. NEC 430.24 covers the use of controllers with motor circuits, outlining the requirements for their installation and operation. A motor controller can be a simple manual starter or a more sophisticated electronic device that provides features such as overload protection, undervoltage protection, and remote control. The selection of a motor controller depends on the specific application and the desired level of control and protection. For a well pump motor, a simple manual starter with overload protection is often sufficient. This type of starter provides a means to manually start and stop the motor, while also protecting it from overloads that could damage the motor windings. Moving on to additional considerations, NEC 551 provides additional requirements for water pumps, specifically those used in recreational vehicles and recreational vehicle parks. While these requirements may not directly apply to a well pump in a dwelling unit, they provide valuable insights into the safe installation and operation of water pumps in general. It's also important to be aware of any local electrical codes or regulations that may have specific requirements regarding well pump wiring and installation. These local codes may impose additional restrictions or requirements beyond those specified in the NEC, so it's essential to consult with local authorities to ensure compliance. Now let's provide some specific recommendations for the well pump installation described. Firstly, it is recommended to use a number 12 American wire gauge THHN or THWN-2 copper conductor for the branch circuit. This size conductor provides adequate ampacity for the 15 amp circuit and minimizes voltage drop. Secondly, it is recommended to install a 15 amp circuit breaker or fuse to protect the circuit. This will provide adequate overcurrent protection for the motor and branch circuit conductors. Thirdly, it is recommended to use a number 12 American wire gauge copper conductor for the grounding conductor. This size conductor meets the minimum requirements of the NEC and provides a low impedance path for fault currents. Fourthly, it is recommended to install a single-pole disconnect switch with a rating of 15 amps or more. This will provide a safe and convenient means to de-energize the pump motor for maintenance or repair. Finally, it is essential to consult local electrical codes and a qualified electrician for final verification and approval. A qualified electrician can ensure that the installation meets all applicable codes and regulations and is performed safely and correctly. In summary, the NEC provides comprehensive guidelines for the installation of well pumped in-dwelling units. By following these guidelines and consulting with a qualified electrician, you can ensure that the installation is safe, compliant, and reliable. Branch circuit wiring must be sized appropriately to handle the motor's full load current, with a minimum rating of 125%. Grounding is essential for safety and must be done in accordance with NEC Article 250. A readily accessible disconnect switch must be installed within sight of the pump. Overcurrent protection must be provided to protect the motor and branch circuit conductors from overloads and short circuits. Motor controllers can be used to provide additional control and protection features, and it's crucial to consult local electrical codes and a qualified electrician for final verification and approval. Understanding these requirements is crucial for ensuring a safe and code-compliant installation. Let's expand upon each of these areas to provide even more detailed guidance. Firstly, concerning branch circuit wiring, selecting the correct wire size is paramount. While a number 12 American wire gauge copper conductor is generally recommended for a 15-ounce circuit, factors like voltage drop and ambient temperature can influence the optimal choice. Voltage drop occurs when the voltage at the motor terminals is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can reduce motor performance and lifespan. To minimize voltage drop, consider using a larger conductor size, especially for long circuit runs. Ambient temperature also affects the ampacity of conductors. Higher ambient temperatures reduce the ampacity of conductors, so it may be necessary to use a larger conductor size in hot environments. NEC Table 310.15 provides ampacity ratings for various conductor types and sizes at different ambient temperatures. Secondly, regarding grounding, ensuring a proper grounding connection is critical for safety. The grounding conductor must be securely connected to the motor frame and to the grounding electrode system at the service panel. The grounding electrode system typically consists of a ground rod, ground plate, or connection to the building's metal water pipe. The grounding conductor should be run in the same raceway or cable as the circuit conductors to minimize impedance. It's also important to ensure that all metal parts of the pump and associated equipment are properly bonded together to create a continuous grounding path. Thirdly, when choosing a disconnect switch, consider the horsepower rating of the motor in addition to the full load current. The disconnect switch must have a horsepower rating equal to or greater than the motor's horsepower rating. This ensures that the switch can safely interrupt the motor's current under load. The disconnect switch should be mounted in a readily accessible location, such as on a wall near the pump. It should be clearly labeled to indicate its purpose. Fourthly, selecting the correct overcurrent protective device is crucial for motor protection. The overcurrent protective device should be sized to allow the motor to start and run without nuisance tripping, while still providing adequate protection against overloads and short circuits. The NEC provides specific guidelines for sizing overcurrent protective devices for motors based on the motor's full load current, service factor, and temperature rise. It's important to consult these guidelines carefully to ensure that the overcurrent protective device is properly sized. Fifthly, when considering motor controllers, several options are available, ranging from simple manual starters to sophisticated electronic controllers. Manual starters provide basic on/off control and overload protection. Electronic controllers offer advanced features such as soft starting, adjustable speed, and remote monitoring. The choice of motor controller depends on the specific application and the desired level of control and protection. For a well-pumped motor, a manual starter with overload protection is often sufficient, but an electronic controller may be desirable for applications that require more precise control or monitoring. Finally, remember that local electrical codes and regulations may impose additional requirements beyond those specified in the NEC. It's essential to consult with local authorities to ensure that the installation meets all applicable codes and regulations. A qualified electrician can provide valuable assistance in navigating the complexities of electrical codes and ensuring a safe and code-compliant installation. The information provided is intended as a general guide and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. By following these guidelines and consulting with a qualified electrician, you can ensure that your well pump installation is safe, reliable, and code compliant. Now, let's discuss some potential issues that might arise during a well pump installation and how to address them. One common issue is voltage drop, which, as previously mentioned, can reduce motor performance. If you experience excessive voltage drop, consider using a larger conductor size or shortening the length of the circuit run. Another potential issue is nuisance tripping of the overcurrent protective device. This can occur if the overcurrent protective device is too small or if the motor has a high starting current. To address this issue, try using a time delay fuse or an inverse time circuit breaker with a higher rating. However, be sure to consult the NEC guidelines to ensure that the overcurrent protective device is still properly sized for motor protection. Another issue that can arise is ground faults. Ground faults occur when a conductor comes into contact with a grounded surface such as the motor frame or a metal conduit. Ground faults can be dangerous and can cause electrical shock. To prevent ground faults, ensure that all conductors are properly insulated and that all metal parts of the pump and associated equipment are properly grounded and bonded. If you suspect a ground fault, immediately de-energize the circuit and contact a qualified electrician to investigate the problem. Another potential issue is motor overheating. Motor overheating can be caused by a variety of factors, including overloads, undervoltage, and inadequate ventilation. To prevent motor overheating, ensure that the motor is properly sized for the application, that the circuit voltage is within the motor's rated voltage range, and that the motor has adequate ventilation. If you suspect that a motor is overheating, immediately de-energize the circuit and contact a qualified electrician to investigate the problem. It's also important to perform regular maintenance on your well pump to ensure that it continues to operate safely and reliably. This maintenance should include inspecting the wiring and connections, checking the grounding system, and lubricating the motor bearings. By addressing potential issues and performing regular maintenance, you can ensure that your well pump installation provides years of reliable service. Remember, safety should always be your top priority when working with electricity. If you are not comfortable performing electrical work, contact a qualified electrician to do the job for you. Ignoring any of these safety guidelines may result in potential harm.